Okay, so completing the square is a topic that you should know from GCSE and certainly from completing the Starting with Confidence booklet. And graph transformations is something that you've probably learnt again in recent weeks. And I want to talk about the link between the two of them because it's one of those areas of mathematics that really helped me appreciate just how wonderful the subject maths really is. Okay, so say we have this equation, x squared plus 4x plus 3 is equal to y. And I want to sketch that. But I'm also kind of interested in where it crosses the x-axis, therefore where it crosses the y-axis, and perhaps what its minimum or maximum point is, where its turning point is. So I'm going to do something that's probably a little bit, for some of you, counterintuitive. I'm going to complete the square on it, but given that our video is about that, it's probably a good idea. So x plus a half b, which is 2, all squared, minus, always a minus, a half b squared, so half b, that should be a 2, it's far too late in the night to be doing videos, plus c, which gives me x plus 2 squared minus 1. Now if I set that equal to 0, x plus 2 squared less 1 equals 0, I can find the roots where that's going to cross. X plus 2 squared is 1, so x plus 2 is the square root of 1, which is plus or minus 1. If you forget that, I'm going to hurt you. And therefore x is either plus 1 take away 2, which is minus 1, or minus 1 take away 2, which is minus 3. So our graph is crossing at minus 1 and minus 3. We know it's going through plus 3 on the y-axis, because if you substitute in x is 0 and x is 0, you're just going to get 3 being y. But what is this turning point? What is this minimum point down here? Well, I know that it's minus 2, minus 1. Partly because I can see it from the graph. It should be, if I had an accurate graph, equidistant between the two roots. And so obviously the midpoint between the two roots there is minus 2. And it's below the x-axis, so the fact that it's negative doesn't surprise me. And actually you may well have seen that. Your teacher at GCSE, or indeed I might have at some point, said, oh, take the bracket and make it equal 0, and that's your x value, whatever the solution to x is, and then just take the plus or minus thing at the end as your y value. Now I'm going to show you why it works. Okay, so here is our completed square form of the previous equation. Now I want you to think about your graph transformations. We have an inside transformation here and an outside transformation here. So let's think about this in stages. We're talking about a quadratic. So let's start with the most basic quadratic we know, y equals x squared. And you can all draw that one. That looks like that. Now let's pick one of our transformations. I'm going to pick the inside one for a moment. So that would look like, ignoring the outside one, x plus 2 squared. Now because it's inside, of course the only thing Mr. Topsy-Turvy does that's normal is live inside his house, so it is topsy-turvy. So this looks like it's going to go in the positive direction, so really it's going to go in the negative direction. So we're going to shove our x is, y squared equals y equals x squared, our quadratic graph, I got there in the end, to the left 2 places. It's going to look something like that. Now, this point that I've circled, or put a splodge on, used to be 0, 0. Always used to sort of touch at the origin. It's now minus 2, 0. And it's starting to look like we've got part of the equation we wanted. We wanted a minus 2 there. And that's come from that shift occurring. Right, now let's combine all 3 things together. So imagine this is like step 3. And now I'm going to, having done my inside transformation, I'm now going to add my outside transformation. So I'm going to take where we were, I'm going to put that in as a yellow dotted line. We were somewhere like that. Now the outside transformations act on the y-axis and behave exactly as you expect them to. So this one is going to go 1 down. Now where has that point moved to? Well, it hasn't moved any distance on the x-axis, that's still minus 2, but it's now gone from being touching on the x-axis to going down 1 in the direction of y, so our y value must have gone down to minus 1. And there's that point, there's that minimum point. It was 0, 0 if you took it to be just the standard quadratic graph y equals x squared. And now that we've applied our two graph transformations, which we found by completing the square, we've gotten our minimum point. And that is why we can find that minimum point the way we can. So it's not just a weird thing that happens in maths, it's because of the rules of graph transformations. So here is just one simple, really easy way to appreciate the complexity of mathematics and how all of these little topics tie up to each other. You can use the completing the square to help you with graph transformations and to find your minimum points. And the reason for that is that when you put a quadratic into the completed square form, you basically give yourself the graph transformation instructions to sketching it. How nice is that?